Please help me welcome Kushagra Vaid.
Thanks, Cole. It's great to be here today. Bonjour. I imagine a lot of you have flown in for this conference. So thanks for being here. I'm excited to be here and excited to share some news with you today on Microsoft's contribution for our second generation server specification. So let's get into that. So before we go into the announcement today, let me just take a step back and recap what we announced back in January of this year. So January, Microsoft joined the Open Compute project. And at that time, we contributed our set of server specifications. These are the same specifications that we use for building hardware that we deploy in Microsoft's own data centers. We called it Open Cloud Server, or OCS. And essentially, this server's infrastructure consists of a chassis and blades. You can see a visual of that on the slide. The chassis was a 12U chassis, and it could accommodate up to 24 servers in that chassis. And then essentially, you put multiple chassis in a rack and multiple racks, and that's how you do deployments in a data center. In addition to the hardware contribution that we made in January, Microsoft also contributed open source software for the system management aspects. So this is basically all the software that runs on the system for out-of-band access, for power management, for fan control. And as you see in the chassis, there is a lot of shared infrastructure, shared fans, shared management, shared power. All the software for managing that was open source as well. So we had a tremendous reception back in January from the OCP community for this contribution. And today, I'm pleased to announce that we are making available to OCP the second generation of the server infrastructure in the same design that we contributed back in January. So this is basically a newer design. It gives a significant amount of performance and power efficiency benefits, and a whole bunch of design features which we didn't have back in the first generation. I'll go through that in some more detail in the upcoming slides. In addition to the hardware contribution today, we are also announcing the availability of open source software for what we call the operations toolkit. So if you think about data center operations, when you're operating data centers at scale, you want to be able to know what's happening with the servers so that you can remotely manage them. You can debug issues. You can ensure that when failures happen, you can find out about them. The operations toolkit allows you to do that, and it's all going to be open source today. The second part of the software contribution that we're open sourcing today is what we call the interoperability and compliance toolkit. This allows any supplier to ensure that the blade and the chassis can interoperate with each other, and that a certain system configuration for whatever your configuration looks like, how many hard drives, how many CPUs, how many racks, the servers in the rack, it can be pre-validated before it goes in the data center. So I'll talk more about that as we go on. So that's the big news today. And this shows essentially Microsoft is committed to advancing the OCP agenda by bringing the learnings from our own experience in operating the world's biggest cloud services and bringing that experience that we learned and have incorporated in our hardware design, bringing that to the OCP community so that the rest of the industry can benefit from the same experience. OCS powers all of our cloud data centers. So if you think about the big cloud services that Microsoft operates, Office 365, which is for online productivity, Xbox Live, which is for cloud gaming, Microsoft Azure, which is public cloud hosting, and of course Bing, which is web searching. All of these large-scale cloud applications are running on OCS. So OCS is not just a specification. It is a full set of hardware that is actually in production and is powering the cloud services today. So that's where we get a lot of our learnings from how to operate data centers at scale. In addition to having a variety of workloads that OCS is designed for, it also is designed to operate in a global data center environment. As most of you know, operating in different data centers across the globe has a lot of challenges. For example, the electrical standards are different, safety, regulatory standards are different. So what we have done in OCS is to make sure that the design can accommodate this variety of standards so that when you deploy this in the data centers worldwide, the deployment is seamless and easy to carry forward with. I'm also pleased to announce today that we have a broad ecosystem of industry partners who are going to be supporting this new design. You can see we have a large number of solution providers across the spectrum of industry participants. And we have a booth where you can go and see the hardware from each of these solution providers. So I would encourage you to go to the booth after the sessions are over. In addition to the solution providers, we also have several component suppliers: CPU, storage, memory, hard drives, networking. All of them are supporting this specification. And there's a lot of some of the optimizations that have been done on the components specific to cloud-specific applications that the component suppliers are driving in support of this specification. So let me go into a little more detail about the specifics of what the contribution is and how it is much better than the previous design and what performance and power efficiency benefits and design features it brings. So essentially, it covers the areas of compute, storage, networking, and memory. On the compute side, to start with, the latest Intel CPUs, the codenamed Haswell, or 2600 V3, the design is built around those. It supports up to 120-watt CPU TDP, which is 14 cores. So you get up to 28 cores in a single server. This is a half-width server. You have two servers side by side. That's a lot of compute power. For memory, there are 16 DIMM slots, which allow you to go up to 512 gigabytes of memory per server node. For networking, what we have done is we have the ability now to go up to 40 gigabits per second on the server node. So it's really high bandwidth networking. And additionally, the networking also supports RDMA over converged Ethernet, or what is known as RoCE v2. In addition to the networking piece, on the storage side, there is an exciting new technology that we're introducing in these servers. So let me pull this out of my pocket. This is the next generation form factor for flash. It's called M.2. It's an industry standard. And this is pretty much what you find in your consumer devices, your laptops, your tablets, other consumer. What we are doing for the first time is bringing this same technology from the consumer world into enterprise servers. This will make flash more accessible to cloud environments at a much more commodity cost point. And at the same time, it will help ensure that we can design a greater capacity of flash, because you can see that it's like a gum stick. It's so small compared to a typical 2.5-inch SATA. There's up to 8 terabytes of flash based on M.2 that can be designed into this platform. So that will allow applications to meet the needs where they need low latency access. There's a by 16 PCI slot on the back of the server to accommodate any expansion cards. If you want to add an FPGA or you want to do higher bandwidth networking or GPUs, the expansion slot will allow you to do that. So it has a capability to do more than just what the server is built with. And last but not the least, we have made some changes to the chassis part of the design as well. Specifically, we have a new custom designed power supply, a 1600 watts power supply, that has been optimized for large-scale data centers. Specifically, what we have done is the power supply has a 20 millisecond hold-up time, so that when you have a power outage and the power goes from utility to generator, the transition point is where a lot of the handover between the two power sources can cause some loss of power to the IT load. So this power supply has been designed to take into account that load transfer so that we don't have any outages, no matter where in the world you're operating, in what kind of data center. In addition to the seamless migration between power sources, the power supply is also very high efficiency, and the power supply designs are going to be contributed to OCP as well. Basically, Microsoft is committed to open sourcing hardware and driving the learnings that we have into the OCP community. The design upgrades and the features that I just talked about are all going to be available on the OCP website, and this includes the entire set of design specifications and collateral. Let's talk a little bit about the software tools that are also part of today's contribution. So you can imagine when you're operating a data center at scale, you have to start to automate things. You cannot have a manual process to find out what's wrong in the server, what has failed, what needs to be replaced, and when replacements happen, how do you make sure that the server is back up and running? To that effect, this is a toolkit, which we call the operations toolkit. This is exactly what we use in our data centers. So this is the real thing that our data center operators use and our service personnel use. And we are open sourcing all of that. It's based on PowerShell. It's completely scriptable. And it consists of 3 main components. The first one is diagnostics, so that you can determine what has failed. Did memory fail? Is the server in good shape? Is it healthy? Are the hard drives up and running? If something has indeed failed, where is it located? Which DIMM stick has failed? What's the hard drive that has failed? How does the operations technician know what to go and replace? The diagnostics will help to identify that. And this is all scriptable and automated. So this will help reduce the repair times. There is a bunch of stress tools that are part of the toolkit as well. So imagine that the service technician has replaced the failed component, and they want to make sure that the server is healthy again with the new component. And the stress tools will be part of this to make sure that the server is back in a healthy state before you can introduce it back in the production environment. And finally, one of the big challenges that we hear in the community is how do you make sure that there is a foolproof way to do software upgrades, BIOS upgrades, firmware upgrades, any other software that resides on the server itself. It's very error-prone at times, and if you do it the wrong way, in the wrong sequence, you can sometimes end up bricking the server. So what we have done in this operations toolkit is made it completely automated and completely error-free. So you enter a command line, and it will do the upgrade. It will check the current version. It will know what the version it needs to be, and it will go and do the upgrade in a very seamless way, reducing human errors and making sure that the servers don't have any unintended downtime. There is going to be a demo of this toolkit in the Microsoft booth. So we're going to do a demo every 30 minutes. So when you get a chance, I would encourage you to go see that. In addition to the operations toolkit, the second part of software we are open sourcing is the interoperability and compatibility. So here, basically, as you see multiple solution providers build solutions that are compatible with this specification, we have to make sure that the servers and the chassis can talk to each other over the management network. How do you know that the interfaces are being met? So the toolkit will help ensure that. So it will help with certification in that regard. Secondly, when you have a rack configuration that has a certain way of connectivity for servers, how is the server configured? How are the servers connected to each other and to the switch? How does that all be validated? The toolkit will help with that. So during system integration and rack assembly, the toolkit will help to ensure that it's all done correctly. And again, this is exactly what we use in our data centers, and this is what we give to our suppliers so that we have error-free assembly and faster deployment times. But all that is going to be available to the OCP community today. So I'm very excited about this. It does allow us to drive our goal of sharing our learnings from our public cloud with the broader community. Here is the entire contribution that we're making today. There is open source code that I just mentioned. There is hardware specifications. There's about 350 pages worth of specifications that will be available on the OCP website. There are board files and Gerber files for the chassis pieces, and there are mechanical CAD models. So all of the design, essentially what you have here is all the design collateral so that you can take this design package. You can, in theory, go to a contract manufacturer and say, build me this thing. It's down to that level of detail. Every little screw, down to that level of detail, that's all there. The benefits of OCP, so we did a study comparing this design to traditional servers. And what we found was that there's about 40% cost savings because of the elimination of unnecessary components and simplification of the design. And there's about 15% gains in power efficiency because of the way the system load is balanced across the different power supplies and the high efficiency of the power supplies itself. And the deployment and service times basically also goes down because now you have tools that can automate the whole process. So all in all, this helps drive the principle of how do we bring cloud scale computing to the masses, and how do we start driving that innovation cycle back into the broader set of ecosystem designs. I would like to basically show you the way the OCP is an integral part of our CloudOS vision. So Microsoft's CloudOS vision essentially spans the different type of clouds that we are designing for. There's, of course, the public cloud, which is Microsoft Azure. We also have clouds that are powered by service providers, which are based on Microsoft technologies. And then, of course, there are private clouds that are deployed at customers. What we are trying to do is to make sure that there is one consistent platform across all these different types of clouds, so that when we drive innovations in our big-scale data centers, that same innovation and the same technologies can flow seamlessly across these different cloud environments. Microsoft happens to be in a somewhat of a unique position where we have a big presence in public and cloud by virtue of Azure and Bing. But at the same time, Microsoft has a significant presence in enterprise also. So by virtue of that position being in public cloud and enterprise, it gives us the opportunity to make sure that there is consistency between these different cloud environments. And by having these contributions go into OCP, it ensures that the hardware platform that spans these multiple clouds is also consistent, so that we can drive the same technologies across the broader industry. To learn more about this announcement today and the contributions we're making, we have a whole variety of talks and booths. First of all, if you go to the booth, you'll see that there are several systems on display there by the different suppliers I talked about. There's a blade from each of the suppliers. There's a chassis. And additionally, there is a demo every 30 minutes for the operations toolkit. So I would encourage you to go and learn more about this and check out the hardware and the demo as well. There is an executive track session tomorrow at 11 a.m. where we'll be talking about what have we learned on the supply chain side of things. It's one thing on the design side, but when you operate at this scale, there's a lot of learnings you have on the supply chain side. What are the learnings we have had from that? We would like to share that with the OCP community as well. And finally, we have technical workshops for those of you who want to learn about all the technical details. Our technical experts are going to be there giving talks on the 4 topics: the hardware overview, the chassis management overview, the operations toolkit, and there's a workshop on server and hardware management. So again, I'm glad to be here. I'm glad to announce that Microsoft is making this 2nd generation specification available to OCP. we are committed to driving the OCP agenda for open source hardware and bringing our learnings from operating large-scale data centers to the broader OCP community. Thank you so much.